Welcome to Module 15, Part 1. In this section, we're going to do an introduction to hypothesis testing. Hypothesis testing is a process where we assess evidence provided by a dataset in favor of or against some claim about the population. There are 4 parts to this process. The first step is to state the claims. There will always be 2 claims in a hypothesis test. The first claim is the status quo hypothesis, or what we are assuming is true about the value of the parameter. This is found by previous studies, known information about the population, or assumptions that you're making about the population. This is called the null hypothesis, and it's denoted with an H and a small o next to it. We call this value HO or H naught. The second claim is an alternative claim about the value of the parameter. So this is what you think is actually happening to the population value. This is called the alternative hypothesis. It's denoted with an H and a small a, or H and a small 1. I use, and your book uses, the H with the small a next to it, but you could also see the H with the 1, most likely in your homework or out in the real world. The second step is to choose a sample and collect the data. If the data gathered does not support the alternative hypothesis, the process stops here. However, if the data gathered does seem to support the alternative hypothesis, this does not automatically mean that your hypothesis is correct. Instead, it means that we proceed to the next step. That step is the assessment of the evidence. This is the piece that actually has the mathematical component, the calculations, to determine whether or not our alternative hypothesis is true. So when we do this, we want to figure out how likely it is to observe the data that we observed if we're assuming the first claim, the null hypothesis, is true. Notice the word how likely implies that we're going to be doing some probability to figure this out. So what we're looking at is, what is the probability that I got the sample mean, or the sample proportion, or the sample standard deviation that I got, if I'm assuming the value should be whatever we have in that null hypothesis. And then finally, the conclusion. So if we find that it would be extremely unlikely to observe what we observed, then we have strong evidence against the first claim and we reject it in favor of the second claim. If we find that assuming the first claim is true, it would not be unlikely to observe what we observed, then we do not have strong evidence against the first claim and we cannot reject it in favor of the second. So we are going to look at the third and the fourth piece of that a lot in parts 2 and 3 of the Module 15 notes. What we're going to look at right now is how to set up the claims, the null and the alternative hypotheses, as well as a little bit of what could potentially go wrong when you're doing a hypothesis test. So when we do a hypothesis test, we can test for 3 different parameters. We can test for mu, we can test for p, and we can test for sigma. So remember, mu is the population mean, P is the population proportion, and sigma is the population standard deviation. We are not going to be doing any hypothesis tests involving sigma. It requires a new distribution that we are not going to be able to cover in the time we have left. We are going to focus on tests for mu and P, because these tests use the normal curve or a bell curve very similar to that normal curve, which we'll talk about later. So there are 3 ways you can set up a hypothesis test. A right-tailed test, a right-tailed test is set up with your null being the parameter that you're testing. So I chose to look at mu. We're going to set mu equal to mu naught, and mu naught represents a number. And then the alternative, HA, is that mu is greater than that same number from our null hypothesis. So this is a right-tailed test because when we're calculating probability and we see the words greater than or more than, we're going to be shading things off to the right. So greater than, shading to the right, so it is a right-tailed test. The next one, the left-tailed test, our null hypothesis looks exactly the same as before. We set mu equal to a number for the population, but now our alternative, we have that mu is going to be less than that number. So less than means we shade to the left, therefore we have a left-tailed test. And finally, our two-tailed test, again, our null is exactly the same, so you say that the parameter, in this case the population mean, is equal to some number. And then the alternative here, we're saying that we don't know whether it could be greater than or less than, we just think it's different from. So the mean is not equal to whatever that value is. And that gives us the two-tailed test. So let's look at some examples of how to set this up. So first example, the mean annual rainfall in Arizona is 8 inches per year historically. However, weather researchers are interested in whether the amount of rain has decreased in recent years, leading to drought conditions in the state. Write a null and alternative hypothesis for this situation. So let's identify some important features to this problem that will help us figure out what we need to do to set up the null and alternative. So the first thing is we see the word mean. So that means we're testing a mean, which means our parameter is going to be mu. And then historically, that value is equal to 8 inches. Okay, so like I said, the value for the null is going to come from prior research, another study, what's been observed in the past, various things like that. So historical research has said that the mean annual rainfall is 8 inches. However, weather researchers are interested in whether this amount of rain has decreased in recent years. So decreased is the key word to tell us whether we're doing a left, right, or two-tailed test. And that is all the information that we need in order to set up this hypothesis. So our null starts HO, and it's going to be mu equals, always equals 8. Because the mean equals 8 historically. So we're going to assume that the mean is going to be 8 again. But now our alternative is that we think the mean has decreased, so we think the mean is now less than 8. And that is our null and alternative hypotheses. So the null is, okay, based on previous years, the mean rainfall was 8 inches. Now the mean rainfall is less than 8 inches, and that's what we're going to try and prove through data collection and analysis. So second example, the Kelley Blue Book price of a used Chevy Corvette is $86,012. Grant wonders if the mean price of a used Chevy Corvette in the Denver area is different than $86,012. So again, we see the word mean, so that tells us we're evaluating mu. This word different is what's going to tell us what type of test we're going to do. And then we're looking at $86,012, which we see in two different places. So we're going to start by assuming that the price of a Chevy Corvette in Denver is $86,012. So that's how we're going to set up our null hypothesis. So HO mu equals 86,012, and then HA mu is not equal to 86,012. Grant doesn't know if it's going to be greater than or less than that value. He just thinks 86,012 doesn't sound right. I don't know if it's higher or lower, so I'm going to test both directions. All right, and then our last example, the Medco pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the FDA wants to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So again, start by highlighting important information. So we have a percentage of children. That's the part that tells us what parameter we're testing. And then we have more than and 2%. So because we're looking at a percent of children, a percent of the population, that means that this is looking at testing mu, not mu, p. Because we see the word percent, that means this is a hypothesis test for p. So our null is going to be p equals, and then 2% is what the other drug, or 2% is how much of the population the other drug affects. So we're going to assume that that's what it's going to be for this new one. And then the FDA wants to know, is the percent getting headaches more than 2%? Because if more people are getting headaches on this new drug, then this new drug may not be worth it. So this is a very real example of something that you would see in the health industry. Okay, working for a hospital, doing research on different medications, this is something you could see. So those are 3 examples of how to set up these hypothesis tests, as well as how to look for key pieces of information in the problem to set it up. So the last thing we're going to talk about is type 1 and type 2 error. So before we talk about this, we want to make an analogy between a hypothesis test and a court case. So in a court case, the defendant is always presumed to be innocent unless they can be proven guilty. With a hypothesis test, the null hypothesis is presumed to be true unless it can be proven false. So that's very important to remember. We're always going to assume that it's true unless we can prove that it's false. So with this, the outcomes to a hypothesis test. The first outcome is that we reject the null hypothesis when the null hypothesis is false. So we said the null is false, and the null was in fact false, so this is a correct decision. This is like taking a defendant that is guilty and finding them guilty. The second outcome is that we do not reject the null hypothesis when the null was true. So we said the null could be true, the null is actually true, so that's another correct decision. This is like where the defendant is innocent and the jury finds them innocent or not guilty. And that's very important. We don't want to ever say that we're accepting the null hypothesis or we find the null hypothesis true, because that's not really what we're doing. All we're saying is that the null, or that the value of the mean or proportion is not less than, greater than, or different from whatever the value was. Okay, so we never are going to end up saying that the null is true. All we're going to say is that it is not false. Okay, and then the third outcome, we reject the null hypothesis when the null is true. So now we've made an incorrect decision. We have an innocent person on trial, and we found them guilty. This is called a type 1 error. It is notated with a Greek symbol. This symbol is alpha, and you can draw this symbol by basically just doing a fish without a tail. Okay? And then the last possible outcome is that we do not reject the null hypothesis when the null was false. Again, this is another incorrect decision. This is where the defendant on trial is actually guilty, but the jury finds them not guilty. This is called a type 2 error. This is symbolized with the symbol beta, which is like a bee with a long tail on the end of it. Okay? There's always going to be a chance of a type 1 or a type 2 error. It is not possible to eliminate those probabilities. And these probabilities are inversely related, meaning as I increase the probability of alpha, it decreases the probability of beta. But if I increase the probability of beta, I decrease the probability of alpha. So as one goes up, the other goes down. Okay, and that's why we can never have a probability of 0 for both of these. So this is an introduction to hypothesis testing. Again, we went through the 4 steps of a hypothesis test. These are overall steps to the hypothesis test. We looked at the 3 ways that you can set up a hypothesis test: right-tailed, left-tailed, or two-tailed. We looked at 3 different examples, and we talked a little bit about type 1 and type 2 error. So that is it for Module 15, Part 1.